Hello, good morning and good evening, whichever part of the world you are watching. This is your host, Mike Espina, and um, tonight we will be discussing the solution for the elimination round 4 of Math Agility. Um, and before we start discussing the solution, let me congratulate the following person. Let me share my screen to you. Okay, these are the following semifinalists. Congratulations to MC or Mac Noriel Baldonado, Cephai Mars Liklikan, Ivan James Lorenzo, Aljon Tumeldan, Aisel Kate Lucero, Sander Banyaga, J. Lord de Vera, Jules Bros Malagum, Kresna Joy Marcos, Art Eliazar Vera, Carl Justin versus Joshua James Javier, Jean Callejo, J. Mark Sodsod, James Michael Espos, William Paul Barbiran, Aljim Flores, Jimmy Nunez, and Ronald Munoz. So congratulations, and we will see you on the semifinals round on June 11. That will be 6 p.m. Friday PST, and that will be June 12, 9 a.m. Saturday Manila time. Okay, so you should be preparing by now for the semifinals round. So let's go ahead for the we call this. So for first is the easy problem. So let's go to easier problem number one. Let me allow to annotate first. Okay, so for question number one, it says find the volume of the solid obtained by rotating the region bounded by the given curves about the specified axis. So the given curve is yx to the fourth and bounded by y equals 1, and it will be rotated about uh, y equals 2. So that would be a horizontal line. So first thing first, we need to uh, graph all of the curves and the boundaries. So I use Desmos in graphing this. So the red line or the red curve would be the y equals x to the fourth. And this would be y equals 2, where we need to rotate the curve. And of course, the horizontal line, which is the boundary of the curve, would be y equals 1. So, of course, intersections for the curve y equals x to the fourth and y equals 1 would be negative 1, 1, as shown here, and 1, 1 on the right side of the curve. So we can use actually a washer method because we will form an outer ring and an inner ring. If we will look on this view of the curve, this would be the effect, right? So let me clear. So this would be the x-axis here. Okay, let me just so you can see everything. So below is the x-axis here, right? But you're looking this way to the curve. So this is the strip, which is the violet line. So we're now facing the strip on this direction. So we will see that it will have an outer ring bounded by the x-axis, which is this, and an inner ring, which is y equals 1, going to the center of our washer, which is y equals 2, right? So this would be the inner ring, and the outer ring of course, and the outer ring would be 2 minus x to the fourth, right? Because of this curve here. This is our curve if you're gonna continue it here. So 2x minus to the fourth, which is the outer ring. Okay. So let's form now the formula for our volume. So this would be uh, the volume would be area of the outer ring minus area of the inner ring times our strip dx, right? So we say that our outer ring is 2 minus x to the fourth. So we know that the area of a circle is phi r squared, right? So for the outer ring, it's 2 minus x to the fourth. So we need to square that because of this. And then, of course, the pi, and then minus the area of the inner ring. So it's 2 minus 1. Again, squared it and times pi, and then our strip dx here. So simplifying this, we will have, and taking out the pi outside of the integral. So this would be 4 minus 4x to the fourth plus x to the 8 minus 1 dx. So this is just a simple integration of polynomials. So after rearranging and simplifying, we have this line x to the 8 minus 4x to the fourth plus 3. So if we integrate it, so this will be x to the ninth over 9 minus 4x to the fifth over 5 plus 3x from the boundary negative 1 to 1, right? And so let's substitute 1. So we have 1 9 minus 4 fifth plus 3 minus the quantity of negative 1 9 plus 4 fifth minus 3. And the final answer would be, the volume would be 208 pi over 45. You can put also cubic units here. All right. If you have any questions, you can write down at the comment section of our Facebook account, on our Twitter, and also on our Instagram account. Okay, so let's move to question number 2, easy round. Okay, so the question, this is a statistics problem. So a study was conducted to measure the effectiveness of hypnotism in reducing pain. The measurements are centimeters on a pain scale before and after hypnosis. Assume that the paired sample data are simple random samples and the difference have a distribution that is approximately normal. Construct a 93% confidence interval for the mean of the before and after differences. So we have a given data. So we have the before data listed on the first row, and on the second row are the after data. So this would mean we will need to take the difference of this before and after data. So let me just move my screen. So we are requested to find the confidence interval in 2 decimal places. So first thing first, okay, I actually transpose my data instead of a row. I put it into 2 columns, which is before and after here, right? And then I computed the DI, or the difference of before minus after. So 12 minus 12.1. Okay, let me change the color of my pen. So 12.1 minus 7.8 would be 4.3, right? And then we need to square that later on. So first thing, we have to take all the differences of the before and after data, right? So, and then once we completed it after the last row, which is 5.1 minus 4.1 is equal to 1, right? Now we will compute the average of this DI. So DI, that will become the summation of DI over N. So we have an N of 8, or 8 samples. And then the summation of DI would be 16.1 here. So if you see the third line after the table, which is D bar here, D bar would be the summation of DI from 0 to N, or from 1 to N, divided by N. So that would, it means we divide the sum of the DI, which is 16.1, over the number of samples, 8, and we got 2.013. Okay, next step is we will be solving the standard deviation. So the fourth column would be helpful for us to compute for the standard deviation. So since we already know the average or the mean, which is 0.013, we need to subtract all of this DI, the third column from 2.013. So meaning 4.3 minus 2.013 is equal to, what's that? 0.13, that is 2.287. And if you square that, this would be the value, which is 5.233. So if you keep repeating that up to the last row and summing it up, so this will give you 18.029. So if you notice, it will be easily computed if you're using an Excel or any technology you prepare. So in this case, I used Excel in computing this. So now we know that our sum of di minus d bar squared is 18.09. We can now use the formula for standard deviation. Okay, so actually in Excel, without even doing this, just drag this information from 5.233 to 1.025, you would be able to compute the standard deviation already. But I want you to show how to compute it manually, okay? So let's clear this. So let's move to the next line. So since we already know that the sum is 18.09, so the formula for standard deviation is square root of the summation of di minus d bar squared over n minus 1. So since we know that the summation, so this is our summation of t sub I minus d bar squared, meaning summation, right? Or the sum of total data we have, right? So that is 18.029, and then our sample is 8 minus 1, and the standard deviation will be 1.605. Okay, so now we're done with standard deviation. We have our average or our mean, sample mean, and sample standard deviation. And next step is to calculate the critical value t of alpha over 2. So how do we compute the critical value? So given that our confidence interval is 93%, right? Given in the formula. And of course, if we draw this, our 93% is in the middle, and each of the end of our standard normal curve would be so 3.5 and 3.5 on each end, right? Because this should be a total of 100%, right? So and we're taking only the critical value. So the critical value would fall on this line. So that would be 93% plus this value here. That's why we divided 7 over 2, because of that will be equal to 3.5%. So our cumulative probability is 96.5%. So again, I used, I call this Excel in computing the critical value of t of alpha over 2. So you need to input this equals t that inverse cumulative probability, comma, degree of freedom. So we already computed 96.5%, and our degrees of freedom is 7. It's simply the total number of samples minus 1, so that is 7 here. And our critical value is 2.1365. Okay, so now we solve the average, we solve the standard deviation, we solve the critical value. Now we're computing the margin of error, right? So the margin of error is critical value times the standard deviation over the square root of the sample. So this is our formula for create for computing the margin of error E. So since we know the critical value at 2.3165, our standard deviation of 1.605, and then our number of sample, which is 8, so square root of 8, so we got 1.212. Now, since we already know our margin of error, we can compute the confidence interval at 93%. So the formula would be d bar, which is our mean, minus E, less than mu of D, less than D bar plus E. So 2.0113 minus 1.212, that's 0.80. And on the right bound, or the upper limit, is 2.0113 plus 1.212. That would equal to 3.22. Okay, so let's move to the question number 3. So easy round, we are still on the easy round. So if you have any questions, you can write down at the comment section of our Facebook page. Okay, so now this is again another calculus problem that deals with work. So it's a combination of calculus and physics. So a bucket was formed by rotating the curve y equals 2 ln of x minus 4 in the y-axis from y equals 0 to y equals 9. So we have this curve and we have this boundary and we have the rotation axis. Find the work done by pumping out a 4-meter height liquid out of this bucket if the density of this liquid is 700 kilogram per cubic meter. So use G equals, or the gravity equals to 9.8 meter per second squared. And we are required to solve for the work done in joules in exact form. So we will not accept if you put it in, call this decimal form, but you will get the point, but not the perfect point if you put it in decimal. So okay, first thing first, again, we need to draw it. So I use Desmos in creating this curve. So we have the 2 ln of x, quantity x minus 4, which is this black curve here. And then our boundary, which is at y equals 0. And another boundary, which is y equals 9 here. So since we are rotating it in the y-axis, so this is our y-axis here, and the liquid is only up to 4 meters. So I draw the horizontal line, 4 meters here, which is the green line. So I would have actually a intersection here between the curve and y equals 4. So if I rotate it in the y-axis, again, I would, okay, let's take, of course, a strip, which is dy. Again here, as you can see, this is the blue strip. No, not blue, but violet strip in the graph. And so let's move to the next. So let me clear this and let's move to the next page. So since we have the dy strip, we need to form our curve in terms of y instead of x. So we need to transform our curve y equals 2 ln of x minus 4 in terms of y. So this can easily be done. So y over 2 equals ln of x minus 4. And then let's raise it to e both sides. So it's e raised to the y over 2. Of course, e to the ln x minus 4. That means it's equal to x minus 4. And therefore, x is equal to e y over 2 plus 4, which is this. So now we transform our curve in terms of y instead of x. And we can now form the volume formula, which is phi x squared dy. So this is a disk method, or so this is a disk method, right? Since we have no outer and inner ring. So if you look top view of our dy, it will just be a circle. Okay, so let's move to the next step. So once we have computed dv, let's compute for the force df. And we know that change in the force would be mass times acceleration. And also we know that mass is equal to density times the volume, or the change in volume, times, of course, acceleration would be, in this case, is the gravity of 9.8. So given the 700 as the density and our dv, which is the whole thing here, so which is the middle part of the equation, times 9.8. So if we simplify this, this would be equal to df equals 6860 pi quantity Ey's over 2 plus 4 squared dy, right? So now we form our df. So the next step would be what? Let's move to the next page. Now we're can now solve the work dw. Okay, so and we know that the d work is equal to force times distance, or change of work equals change of force times distance. So since our distance is actually from 9 minus y, right? We're pumping out. So the level of the water would change based on how whatever is left, or whatever is the amount of water left in the funnel or in the bucket. Okay, so that would be, since the height, if you go back, let's go back first to the drawing. So the height of the bucket is at y minus 9, and we have a level of the liquid at y equals 4. So the value from 9 up to this would change, right? So because y, of course, would be, uh, as we pump out the water, this would go below y minus 4 until we reach y equals 0 here, right? So we can represent the distance as 9 minus y from here up to here. Okay, up to dy actually. So let's go back to that page where we are computing the work. So we already formed the formula for work. So let's rearrange and turning the work dw to w, and we know that we can do that by integrating our formula. And since the limit is from y equals 0 to 4, which is the height of our liquid, right? And this would be our final formula. W is limit from 0 to 4, 6860 pi, quantity Ey over 2 plus 4 squared times 9 minus y dy. So again, rearranging and simplifying and distributing all, multiplying these two uh, numbers in the expressions in the parentheses, we would have this formula here. So actually, to save time, I use an integral calculator for this. It's allowed since you already form, if you form this equation and you would need technology to save time in solving, you can do that. As long as you form the correct equation here, and the final answer would be 6860 pi quantity 6e to the fourth plus 112e squared plus 262 joules. So this is the exact form. There would be other form than this. I also accepted that answer because they are also equal. So you'll get the whole 1 point for this. Okay, so let's move to the next problem. So that would be uh, problem number 4. So let's read the problem. Alden and Marjo have a race. Marjo gets a 500-foot head start, but Alden runs at 5 foot per second, whereas Marjo only does 0.05 feet per second. So that's the speed. So when Alden reaches Marjo's starting point, Arjo has moved a short distance ahead. When Alden reaches that point, Marjo again has moved a short distance ahead, and so on and so forth. Main claimed that Alden would never catch Marjo. Is Main correct or not in her conclusion? So uh, the question requires us to solve the total time. And then for B, what's our conclusion? Is Main correct or not in her conclusion? So that's the second question we need to answer based on our calculation. So here I created a table for Marjo and Alden's head start and speed. So Marjo had a 500-foot head start and his speed is 0.05 feet per second, while Alden has 5 feet per second speed here. So let's compute first the time can reach Arjo's starting position. So at 500 feet divided by, so we know that D equals RT, right? So T is D over R. So our D is 500 feet, and then the speed, Alden's speed is at 5 feet per second. So we have 100 seconds needed to reach that point. But at the same time, so when Alden is trying to catch, reaching that starting position, Marjo is actually advancing a distance of, so at 100 seconds, the distance traveled by Marjo is 100 seconds times 0.05 feet per second. That is his speed, right? Marjo's speed. So he would move 5 feet after 100 seconds. So again, let's go back. Alden can cover that 5 feet. So how many seconds can Alden cover that 5 feet? So let's clear this. Let's move here. So the required time would be 5 feet divided by his speed. Alden's speed at 5 feet per second. So that would require actually 1 second, right, of time. Again, where Arjo moved again a short distance of in within 1 second, he would move 0.05 feet. So let's go back to Alden again. So to cover that zero point zero 0.05 feet, the time required for Alden is 0.01 second. And again, Marjo would move a distance at that specified time of 0.01 second, right? So let's multiply that time again by his speed. So it would he would move point zero zeros, so 3 zeros and 5 feet. So this would continue infinitely, so and so on and so forth. So the distance and time are both approaching zero, as we can see, right? The time involved in the series is 100, and then 1.01 plus 0.0001. So that's the time we noticed from the computations we did for Alden. And this is actually a geometric series if we take the ratio of 1 over 100, this is this, and then 0.01 to 1, and this value here to 0.01. Oops, it was deleted, but there should be a 1 here. Uh, oops, why it was, the value would be 0.01, right? So, okay, hold on. Just give me a second. So this should be 1, and this should be 0.01. So the ratio that we will be solved being in this formula would be 0.01. Okay, so we can use the formula below to get the sum of the time, right? In our summation of geometric series, that would be A, so the first term, over 1 minus R, which is 1 minus the ratio of 1 over 100, or 0.01. And we will get 10,000 over 99 seconds. So if you get the decimal equivalent of 10,000 over 99, that is approximately equal to 101.01 seconds. So, of course, Main is not correct in her conclusion. Alden would, of course, be able to catch Marjo on this time of 101.0 seconds. Okay, so let's move to the next question. So this will be the fifth question in the easy round. So this is a statistics problem again. So you have, if x and y are any random variables, um, prove that the expectation of their sum is the sum of their expectation. So we are required to do, of course, show our proof and then the conclusion of our proof, right? So in mathematical symbol, so let me just do this a little bit. We need to prove expectation of the random variable x plus y, which is this, is equal to the sum of the expectation of h, right? Which is expectation of x plus expectation of y. So we can assume two kinds of function for this. First is it can be discrete, and the second is it can be continuous, right? It can be discrete data or continuous data. So uh, when we assume that it's discrete, so the formula would be E quantity x plus y. So expectation of the random variable x plus y would be summation of x and summation of y, quantity x plus y, function of x and y. So we can split this into two, distributed. So summation of x and y is x times f of x of y plus summation of x and summation of y, y function of x, f of x and y. So this would mean the first part would be equal to summation expectation of x, and the second term would be the expectation of y. Now, if we will assume that our function is continuous, so we will use the integral of x of y, f of x of y, dx dy, right? Because we have two variables in terms of x and y, and our limit is from negative infinity to infinity for both the integral sign. And of course, we can again distribute this into two terms. So one is the part where x, f of x, dx, dy, and the second term would be y, f of x of y, dx, dy. So the first part would mean this is the expectation of x, and the second part would mean this is the expectation of y. Okay, so we have proven that expectation of quantity x plus y is equal to expectation of x plus expectation of y. Okay, so before we will be continuing our solution for the average problem, let's pause for a short break. And if you have any other questions, you can write down in our comment section below. So we'll see you in a bit.
Kids dread math, but unfortunately, parents are busy juggling responsibilities and are unable to help their kids with their math homework. High school and college students find math to be difficult and need help with their math and advanced math subjects, while working college students don't even have enough time to study for their math homework. It all boils down to the fact that to ensure continuous success for students in their mathematical study, getting the right help is most important. Unfortunately, current solutions only deliver hours of math preps without spaces for students to even ask their troubling questions. We understand the flaws of these methods, and we've crafted a new solution that works for all students, even low-class junior students. Introducing the the Math Agility Math Express 10, Math Express 20, Agile Max 15, and Agile Max 30. The simple but effective solutions to help students through their math difficulties and homework. At Math Agility, we are focused on providing quality tutorials and test preparations to increase the confidence of students with math concepts and problem solving. And with each subscription package, every student gets to enjoy access to math support like never before. The Math Express 10 allows students to ask 10 questions, valid for 7 days. The Math Express 20 allows students to ask 20 questions, valid for 30 days. The Agile Max 15 allows students to ask 15 math questions weekly, while the Agile Max 30 allows students to ask 30 math questions monthly. Now, busy parents can worry less knowing their kids have the best math help while in high school. College students and working college students can get the help they need with their homework. Getting started is easy. Simply create an account, log in, choose a subscription package, pay, and that's it. Start asking your math questions and get the help you need. Visit www.math-agility.com.
Okay, we're back. So let's again solve the average problem 6 to 10. So let me share my screen again to you. Okay, hope you can see this. All right. So average question number one is again another statistics and probability problem. So a continuous random variable x has a probability density given by f of x. So 2 to the e to the negative 2x when x is greater than 0, and it will be 0 when x is less than or equal to 0. So find the expectation of the continuous random variable x and the expectation of the square of x. So required is, of course, we need the solution. That would be 4 points, 0.4 points. Expectation of the continuous random variable x and expectation of the square of x. So finding first expectation of x. So we will use the formula e of x equals negative uh, f of x dx from negative x to infinity. So uh, let's substitute our f of x, which is our density. So 2e to the negative 2x times x, and that would be only from 0 to infinity. And so if we try to integrate this, okay, so this time I didn't use any integrator calculator. I use integration by parts to solve this integral. Okay, so x e to the negative 2x would be equal to uv. So we let u equals to x. And if we try to get the derivative of that, that would be t du equals dx. And dv is the other part, which is e to the negative 2x. And if we take the integral of that, that would be v equals negative 1 half e to the negative 2x. So combining them, so the formula is uv minus integral of b du. So uv, u times b, which is x times negative 1 half e to the negative 2x minus the integral of v du. So v and then times the du, which is this, negative 1 half e to the negative 2x dx. So again, we let u equals to negative 2x and du equals negative 2x by algebraic substitution, and you will get the integral of this expression here as 1 half quantity negative 1 half e to the negative 2x. And of course, we can simplify this. So this is the simplified form. Negative x over 2 e to the negative 2x minus 1/4 e to the negative 2x. So let's go to the next part. So we go back to the original integral, and if we try to substitute our boundary from 0 to infinity, we will get e expectation of x equal to 1 half or zero point 0.5. Okay. So now we solve the first requirement. Now let's solve the second requirement, which is the square of x, right? Okay, so this time instead of x, we're squaring x. So x squared, f of x dx, which is our formula. And again, our limit will be from 0 to infinity. So substituting our our function, which is 2e to the negative x dx. Again, by using integration by parts, we will get uh, 1 half, negative 1 half x squared e to the negative 2x plus integral of x e to the negative x dx. So we already know that this term here, the second term, would require another integration by parts. So that's what we did earlier for the first one. So if we try to use integration by parts, again, we will get this value here. So this value, the first part, plus the integral of this, which is this value. Let's combine them, and we will get negative 1 half x squared e to the negative 2x minus 1 half x e to the negative 2x minus 1/4 e to the negative 2x, right? So this is actually equal to our expectation of x squared, a random variable x squared. And if we try to get the value from 0 to our infinity, which is our limit, this would be, so let me just clear it. So this would be 0, negative 0 minus 0 minus 0 minus the quantity, negative 0 minus 0 minus 1 half. So minus minus, so this would become positive. So expectation of x squared is also equivalent to 1 half or zero point 0.5. Okay, so let's move to our next problem, which is average A2 or problem number 2. So you are conducting a study to see if the proportion of men over 65 who regularly have their prostate examined is significantly different from 0.34. You use a significance level of alpha 0.02 and you obtain a sample size of n equals 354. So your number of samples 354, in which there are 150 successes. So the requirement is we need to state the null and alternative hypothesis. Number 2 is find the population standard deviation in 4 decimal places. And 3 is we need to find the test statistic for the sample in 4 decimal places. Number 4 is the p-value in 5 decimal places. And 5 is the conclusion by explaining first the decision of rejecting the null, accepting the null, or fail to reject the null. So we'll try to find out this. So answering this 5 question would give you 2 points, so 4 points each. So let's go to number 1 requirement. So the null and alternative hypothesis. So of course, given the population standard deviation or the historical value for the prostate examined is at 0.34. So our null hypothesis HO would be P equals 0.34. Remember, always use equal for P for null hypothesis, and then H1 should not be equal to 0.34 because that is the claim, right? That is not equal, or if it's equal, to 0.34. That's what we're trying to prove. And then number two is to find the population standard deviation. So since these are proportion, the formula we'll use would be sigma equals the square root of p minus 1 minus p over n. So our p is already 0.34, right? So remember, we're calculating the population standard deviation. So we should use the population proportion, right? So that is 0.34. And computing that, we will get our population standard deviation sigma is 0.0252. Okay, so let's move to compute the test statistic. So let me just move this page. So to compute for the test statistic z, so p prime, we know that the number of successes is 150 and the total number of sample is 354. So p prime, sometimes they use p hat for the values of the sample proportion. So 0.424 would be the sample proportion. So, and then the formula for the test statistic z would be p prime minus p. So the difference of the sample proportion minus the population proportion p divided by the standard population standard deviation, or you can also recompute it here, but the denominator is already equal to 0.0252, right, which we have computed earlier. So just get the difference of this and divide by 0.0252, we will get 3.336 as our test statistic, sorry. And then let's go for number 4, which is the p-value. So we know that this is a two-tailed test based on our hypothesis, right? So it's either equal to 0.34 or not equal to 0.34. So that's a two-tailed test. So we should multiply our p-value twice. So if you draw it, so what we will be solving in our p-value, which is the one inside the bracket, would be from here up to here. So if you subtract mm, 1, you will get this value, the one in the shaded portion. So since it's two-tailed, so there should be another one on the left-hand side of our distribution. That's why we multiply it by 2, right? So 1, if you use Excel, so 1 minus norm this, 0.424, which is our proportion, sample proportion. And then the population proportion, 0.34. And input also, this is the population standard deviation. And true means here it is cumulative. Right? It's cumulative starting from here up to this critical value here. And we will be able to solve 0.0086 as our p-value. Okay, so let's now move to the fifth question, which is the decision. So let's compare the value of our p-value to alpha, which is 0.02. So since it's our p-value is less than our alpha of 0.02, we reject the null hypothesis. In case if it's greater, then um, we would be able to accept, right, the null hypothesis. And we should be saying that fail to reject the null, right? We don't say accept the null, but we fail to reject the null. And then therefore, there is sufficient evidence, sample evidence to support their claim that the proportion of men over 65 who regularly have the prostate examined is different from 0.34, right? Because our null hypothesis, we said, is that the population proportion is 0.34. Since we have the sufficient sample evidence to reject it, therefore we can say that it is different from 0.34. Okay, so let's move to the next question, which is A3. So actually, this question was given on our last elimination round 3. So it's a repeat question. So if you watch episode 13, the episode before this one we're currently doing, the solution was also explained there. But of course, let's solve this again. So a new Pokemon ball named as Agility Ball is being tested and thrown in the air at time t equals 0. It describes a parabolic trajectory s of t in the xy space, where the x-axis is the ground and the y-axis is the distance from the ground. Okay, so s of t is given as t and wt minus gt squared over 2. So it's a matrix. So compute the velocity vector vt and acceleration at of the ball. So that's the first requirement. Second is we need to compute the unit tangent vector ut of the trajectory. And the third requirement is to compute the tangential acceleration of the ball and find when it is 0. And then the fourth requirement is, so there is a explanation here. The agility ball spins in the air as designed so that the trajectory of the air valve so this is the air valve t s of t plus the s cosine omega t and s sine of omega t. So we are required to find the norm of a bulb of t, or the acceleration of the air bulb, the magnitude of the acceleration of the air bulb. So if you solve this, you would get 2 points. If you answer all the four questions, so each would be 0.5 points or half point. Okay, let's clear this. Let's move to the solution. So the first is we're computing the velocity and the acceleration at. So we're just getting the derivative of st, which is equal to vt, right? So taking the derivative of st would be equal to 1 and w minus gt. Okay. Next, again, if we compute the acceleration, that is the derivative of bt or the second derivative of st, right? So if you take the derivative of that, derivative of 1 is 0, derivative of this and with respect to t would be negative g, right? So if you got this, you get 0.5 points. And then let's compute the unit tangent vector ut. So the formula would be u hat equals v hat, which is equal to v over the magnitude of b. So magnitude of b is simply the square root of 1, which is this, and the square of this one here, right? Times the actual b, which is the matrix 1 over 1 w minus gt. So combining them, so simplifying, we have 1. Of course, 1 squared is 1, and I did not expand on this, but you can also expand it. But you would get already uh, zero point 0.5 points if you have shown this answer. Okay, now for number 3, the requirement is the tangential acceleration of the ball when it is 0. So let's compute first the acceleration at a sub u, which is acceleration times u. So it means this value of a of 0 and negative g, let me clear this, multiply by this amount or this value here, right? So combining them, so the first 0 times this would be, of course, 0, and the negative g times this value would be what is left in our answer, right? So you can also manipulate this to make it positive if you want to distribute the negative inside the parentheses. So g over gt minus w divided by 1 plus W minus GT quantity squared. So you can answer this without the negative, or you can also have this answer. But either you will get already zero point 0.5 points. Okay, let's move to the next requirement, which is hold on. So we're not yet done with number three. So when AU is 0, so simply substitute that and find the value of t. So right, so this is equate this to 0. So of course the denominator would be equal to 0. And what is left is the numerator, and that would be g. So g equals 0 and gt minus w equals 0, right? So t would be w over g. So this would be the answer. Okay, so let's move to getting the magnitude of the air bulb in function of t. So we are given this data, right? So S bulb equals S of t plus S of cosine omega t and S sine of omega t. So simply get the second derivative of S bulb to get the air bulb t, and we will have this equation here. Air bulb AT plus second derivative of S cosine omega t, S sine omega t with respect to time squared, right? So this would mean, since we already know A of t, right, plus the second derivative of this part here. And that is negative omega S omega squared cosine omega t, negative S omega squared sine omega t. So combining, adding, or summing up the two matrix. So we have, since it is 0, so what is left is S omega squared uh, cosine omega t, and the second row would be negative g minus S omega squared sine omega t. So since we have this as our x and our y, right, we can now solve for the magnitude, which is simply squaring and taking the square root of the sum of the squares. So which is what we did here. So this would be on this part, and we square it, and the y is this part, and square it. So simplifying it and combining, actually you will get a sine squared and a cosine omega squared. So this has the sine squared, and the first term has the cosine omega squared. If you combine them, factoring out s squared omega 4 to the fourth, I mean, so this would be equivalent to 1, right? In trigonometry, cosine omega squared of t plus sine squared omega t is equal to 1. So we eliminate that. And what is left is the square root of s squared omega to the fourth, g squared plus 2g s omega squared sine omega t. So this would be the norm or the magnitude of a bulb of t. Okay, if you have any questions, you can write down at the comment section below. So let's move. Oops, let me clear this first. To question number 4. So just give me a second. So the question is, Donna intends to purchase a gift for Eclair using her Macy's voucher. So Macy's is actually a big mall here in the US. So Donna has 3 vouchers, but only one can be used. So the first voucher is 15% of the listed price if the listed price is at least 500. Second voucher is $100 off the listed price if the listed price is at least $1,000. And then the third voucher is 20% off the amount by which the listed price exceeds $1,000. So at what price will the first voucher offer a greater price reduction than either the second voucher or third voucher? So the final answer would give us 2 points. So Let's first do our representation. So let x be equal to our listed price. And it can also be assumed that x should be greater than or equal to 1,000 because the second and third voucher can only be used on this amount. So we have this criteria or we have this requirement. So if Donna uses all the vouchers, the following will be the cases. So for voucher one, that's 15% of X of the listed price. The second voucher would be $100 off. And the third voucher would be X minus 1,000. So if you simplify that, that would be 0.20x minus 200. So for voucher one, to have a greater price reduction than voucher 2 and 3, so we can have 0.15x greater than 100 for voucher 2, right? This. And voucher 1 greater than voucher 3, which is this. So solve them. So x would be dollar of 66.67, and the next equality would be x at less than 4,000. So if we combine them, everything we know, we cannot be lower than 66.67, right? As we have noted this. So the price ranges for voucher 1 is better than the other two vouchers, so it'll be at x greater than or equal to 1,000 but less than $4,000. Okay, so let's move to our last question for the average round. So that's A5. Again, this question is given uh, in Elimination Round 3. So if you watch episode 13 of Math Agility Live, you would be able to solve this problem. Okay, so but let's read this again. The robot Mac AG has an extensible robotic arm which is set to rotate around the origin with a time-dependent angle omega t. The robotic arm can change its length m of t using a piston system. Oz, the programmer for Mac AG, has the goal to program the piston system such that the free extremity is constrained to follow the line y equals mx plus b. Okay, so I think this drawing is also given in the problem. So we have this graph or diagram. So the question is find the expression for m of t and solve when the y-intercept is 5 and the angle is 30 degrees at time equals 1 second. So that's the requirement. The initial values actually were changed. So if you notice in episode 13, I think this is 45 degrees and this is 10. So this was 10 and this was 45 degrees. So we changed it to 5 and 30. So if you just copied the solution, you get wrong answers. You will get the wrong answer for requirement number 2. So given the boundary condition. So okay, let's see the solution. So the first position vector of free extremity of the robotic arm of Mac AG is given by S of t. So uh, the segment OD of t equals mt. So mt multiplied by this is actually your x component and y component, right? Cosine omega t, sine omega t. So let's see the drawing first. So right, so if you try to draw this, so this would be your mt, right? So this is cosine omega t and sine omega t, your uh, y component. So multiplying mt by those components, which is actually what we did here, right? But in vector or in matrix form. So in order for this position to be a point on the line y mx plus b, the following must be true, right? So mt sine omega t, so that's our y, right? mx, so the slope m times x, so the x would be mt times cosine omega t, right? Plus our intercept b. Okay, so now we form the equation of the line using these parameters here, and we will be able to solve MT from here, right? This is just algebra, so MT would be equal to B over sine omega t minus M cosine omega t. So the initial values given is that when intercept is 5, y-intercept is 5, omega is 30 degrees, and time is t is 1 second. What is M? So M of 1 second would be equal to, although why did I write 10 here? So this should be 5. So 5 over 1 half minus, so sine 30 degrees is 1 half minus M cosine 30 degrees is square root of 3 over 2, right? So that should be the final answer for M at 1 second, right? So, so this should be the final answer here. Okay, hope you get that question. So if you answered that, you would get 2 points as well. So again, let's pause for a break and we will come back. When we come back, we will answer the difficult question 1 to 5. So see you in a bit.
If you are weak in math or have less time studying because of work, then Agile Max and Math Express will be immensely helpful for you. Using Agile Max and Math Express is something easier, and you have to follow these steps. For creating an account, log into www.math-agility.com. Click the icon on the top right corner. There will be an option available for creating account. After clicking the Create Account, this page will appear. You have to fill all the details, like first name, etc. Check the box, I am not a robot, and then click Submit. You will receive an email about account confirmation. For existing customers, first click the icon to log in, input your details. You will see an option of subscription and click Subscription to choose the package that will fit your needs. The subscription package will show different variants of Math Express and Agile Max. Click Buy Now of the product you want to purchase, and then click View Cart, and then click the Checkout. After this, input your billing address and click Continue to Payment. Choose Payment Method and then click Pay Now. Click Math Agility to go back to your account page, or click Continue Shopping to buy more. For updating the Student Dashboard profile, click the Student Dashboard and fill up your information. Asking Math Questions by Students. To ask math questions, click the Ask Questions and choose your subject. You can type your question and can attach a file. You can view your posted questions in the question list and the remaining unused questions. When you click View from the question list, this page will appear. The math experts from Math Agility can see the questions and can reply with a solution. When students click View, they will see this page. If the student is satisfied with the solution, then they can click on the Close Questions.
Okay, welcome back. So let's move on to the difficult question 1 to 5. Let me share my screen. Just give me a second. Okay, so difficult question number 1. So let's read. Pio was testing the transformation x of alpha cosine theta and y alpha sine theta if the equation second partial derivative of u over partial derivative of x squared plus second partial derivative of u over the partial derivative of y squared is equal to 0. So will that become to second partial derivative of u with respect to alpha plus 1 over alpha partial derivative of u with respect to theta plus 1 over alpha squared second partial derivative of u with respect to theta is equal to 0. And she concluded that after computing that it will not be in that form. Is Pia correct or not? Is she correct or not? So the requirement would be, of course, a solution and what will be our conclusion based on what we will be computing. So first, let's define the partial of u with respect to x and partial of u with respect to y, which is these two equations, right? So partial of u with respect to x is equal to partial of u with respect to alpha, partial derivative of alpha with respect to x plus partial derivative of u with respect to theta times partial derivative of theta with respect to x. And also, that's equation A, right? Oops, sorry. That's equation A. And then for B, so that's partial derivative of u with respect to y is equal to partial derivative of u with respect to alpha times partial derivative of alpha with respect to y plus partial derivative of u with respect to theta times partial derivative of theta with respect to y. Okay, let's now differentiate x equals alpha cosine theta and y sine theta with respect to x, keeping in mind that alpha and theta are function of x and y. So these are both function of x and y are both functions of alpha and theta. So we would have for x alpha cosine theta. So let's first product rule, right? So derivative of x, partial derivative of x is 1. So let's try to get the derivative of cosine theta. So we'll just copy alpha and cosine theta derivative is negative sine theta. That's why you have a negative here with respect to partial derivative of theta over partial of x, right? Now let's take the derivative of alpha. So that's is this part, partial of alpha with respect to x. And then we just copy the other function, which is cosine theta. So similarly with y equals alpha sine theta, so um, we're taking the derivative with respect to x. So y would be a constant. And if we take the derivative of a constant, that would be 0 here, right? And similarly, we know that these are functions of alpha and theta. So let's take the derivative of sine theta first. So keeping alpha here. So that would be cosine theta, partial derivative of theta with respect to x. Now let's take the derivative of alpha. So that's partial derivative of alpha with respect to x sine theta, right? We just copy that one. So we form equation 1 and equation 2. So by solving this equation simultaneously and first rearranging equation 2, so we have equation 3, which is negative alpha cosine theta over sine theta partial derivative of theta with respect to x. Okay, so if we substitute equation 3 in equation 1, so again, this is algebra, we would get equation 4, which is equal to partial of theta, which with respect to x equals sine theta over alpha. And don't forget the negative here, right? And then the next step is let's substitute equation 4 to equation 3. So we will get the value. So for in equation 4, we already get the value partial of theta over partial of x. And then when we substitute this equation to 3, we would get partial of alpha with respect to x, which is here it says it's equal to cosine theta, which is equation 5, right? So we're done with respect to x. Now let's do differentiating with respect to y. So the equation x equals alpha cosine theta and y alpha sine theta. And again, keeping in mind that alpha and theta are a function of x and y. So this time x would be constant, right? Because we're taking partial derivative with respect to y. So clearly, we x equals alpha cosine theta. So that would be 0 since with respect to y. And then product rule of differentiating, we will get this. That's equation 6. On the other hand, when we get the partial derivative of y equals alpha sine theta, we have 1 equals alpha cosine theta, partial of theta with respect to y, plus sine theta partial of alpha with respect to y. That's equation 7. So solving this again simultaneously, we would get equation 8. So that's partial of alpha with respect to y is equal to a alpha sine theta over cosine theta, partial of theta with respect to y. So we already get partial of theta with respect to y. The next thing we will need to solve is partial of theta with respect to y, right? Okay, so we can do that by substituting equation 8, which is this equation, right, to equation 7. So we will be able to solve partial of theta with respect to y, which is equivalent to cosine theta over alpha, and that would be equation 9. Okay, so the next step is to substitute this equation 9 to 8, and we would get the value of partial of alpha with respect to y, and that would be equal to sine theta. That's equation 10. So if we take equation 4, 5, 9, and 10 and substitute it in the initial equation a and b. So let's go back again. Oh, sorry. Let's go back. What is equation a and b? That's what we defined earlier for partial of u with respect to x and partial of u with respect to y. We already have the value for partial of alpha with respect to x and partial of theta with respect to x. Same thing with the y. Partial of alpha with respect to y and partial of theta with respect to y. Right? So these are our two equations for a and b. So let's go back here. So when we substitute those values in a and b, we will have equation 11, which is partial of u with respect to x equals to cosine theta, partial of u, partial of with respect to alpha minus sine theta over alpha, partial of u with respect to theta. And then partial of u with respect to y is our equation 12, and that is equal to sine theta partial of u with respect to alpha plus cosine theta over alpha partial of u with respect to theta. So consequently, the second partial derivative of u with respect to x is actually equal to partial derivative of the partial derivative of x with respect to x. And it is also equal to partial derivative of the partial derivative of x with respect to alpha times partial derivative of alpha with respect to x plus partial derivative of the partial derivative of u with respect to x with respect to alpha times partial derivative of alpha with respect to x. So if we try to substitute equation 11, this equation, right, to this second partial derivative, we will have this long equation here. So, um, hmm, so we will get equation 13. So partial derivative, second partial derivative of u with respect to x would be equal to, after manipulating this long process here, we will get cosine squared theta partial derivative, second partial derivative of u with respect to alpha squared plus 2 sine theta cosine theta over alpha squared partial derivative of u with respect to theta minus 2 sine theta cosine theta over alpha second partial derivative of u with respect to alpha n theta plus sine squared theta over alpha partial derivative of u with respect to alpha plus sine squared over alpha squared second partial derivative of u with respect to theta. And similarly with y, right? So this is with respect to y to x. We will get the same thing for same process for partial derivative of u with respect to y, which is, so this is again our guide for getting the second partial derivative of u with respect to y, which is the partial derivative of the partial derivative of u with respect to y with respect to y, or it is equivalent to the partial derivative of the partial derivative with respect to y with respect to alpha times partial derivative of alpha with respect to y plus partial derivative of the partial derivative of u with respect to y, partial derivative of theta times partial derivative of theta with respect to y. So again, if we substitute equation 12 uh, in this equation, we will have our final answer, which is equation 14. So partial derivative, second partial derivative of u with respect to y would give us this long equation here. Okay. And then if we try to add, so this is the requirement, adding both the second partial derivative of u with respect to x and with respect to y. So adding them together and equating to 0. So we equate this to 0. We can simplify this, manipulating this. So we can combine again sine squared cosine squared, which is actually equal to 1, right? And the rest. All right. So once we simplify this, we would get second partial derivative of u with respect to x plus second partial derivative of u with respect to y is equal to second partial derivative of u with respect to alpha plus 1 over alpha partial derivative of u with respect to alpha plus 1 over alpha squared second partial derivative of u with respect to theta equal to 0. So again, Pia has an incorrect solution because we already have proven that it would transform to the given equation here. Okay, so that's a long solution. So that's why it's in the difficult question. Okay, so let's move to the next question. So, so this is what we said. No, it transformed to this equation here. So let's go to question number 2. So this question is also given in Elimination Round 3. So if you watch episode 13 of Math Agility Live, you would be able to solve this. So D2 is Sensen observed that curve A is a set of points x and y such that x equals s plus 1, y equals negative 2s plus 3, where s is a real number, while Umeno observed that curve B is a set of points x, y such that x equals negative 2t plus 2, y equals 4t plus 1, where t is a real number. Sensen computed that curve A will have no common point. So that's what his claim. No common point to curve B, while Umeno, so contrary to Umeno's computation that there will be one common point. So Sensen said no, 0, and Omeno 1, right? One common point. So we are required to find the number of common point or points. So, and it says here number of common points. Try to find that. And who has the correct computation? Is it Sensen or Umeno? Okay, so this is a parametric curve. So we can eliminate S, the variable S in curve A. So by transforming S in terms of X, that's our equation 1. And also Y in transforming Y in terms S in terms of Y, which is equation 2. And then equating 1 and 2. So we eliminated the variable S and we got 2x plus Y equals 5. Okay, so let's go to curve B. This time we can actually eliminate the variable B. So let's transform our equation instead of in terms of T, let's put it T in terms of X, which is equation 3. And also let's transform Y equals 4T plus 1 in terms of Y, which is equation 4. And then similarly to what we did, we equate 3 and 4 to eliminate the variable T, and we have 2x plus Y. So since both curve A and curve B are straight lines, they are exactly the same line, they are coinciding with each other, the number of common points would be infinite. So not both Sensen and Omena's computation were not correct, right? So you get 4 points if you answer this correctly. Okay, let's move to question number 3. Again, this was given in elimination round 3. And so let's answer this. Newton said that it is possible to express Q and S each in terms of P and R using the polynomial equation below. When it has two double roots U and V, where U may or may not equal V, prove Newton's claim is possible, right? X, so this is the polynomial x to the fourth plus px cubed plus qx squared plus rx plus s equals 0. So the expression for s, that would be 2 points if you answer that, and the expression of q would again be 2 points, right? In terms of p and r, that's the requirement. So since each of the factors x minus u and xp appears twice, so we can actually equate our polynomial with that. So x minus u, x minus u, x minus b, x minus b, that's equation 1. So what I did here is that I expand the right hand side of the equation. So which this is the right hand side. I expand this and I got the value x to the fourth minus 2b cubed plus b squared x squared minus 2u x cubed plus 2uv x squared plus 2uv x squared minus 2u b squared x plus u squared x squared minus 2u squared vx plus u squared v squared, right? So we can rearrange that. So you would need art in doing this. It took me some time to do this. So, and if after rearranging, you would get this factor x squared minus x quantity u plus b plus uv quantity squared. So if we let u plus b, which is the one in the middle term, equal to negative b and uv equals to c, we will get this form x squared plus bx plus c, right? So we simplified our equation to a normal quadratic equation which has factors or um, coefficient of b and of course constant c. So and then so we have, so what's our next step? So we have from equation 1, right, equal to X squared plus bx plus c quantity squared. Again, expanding the right hand side, we will get this x to the fourth plus 2bx cubed plus 2bcx plus 2cx squared plus b squared x squared plus c squared. So if we arrange this, rearranging, and this would be x to the fourth plus 2bx cubed plus 2c plus b squared quantity x squared plus 2bcx plus c squared. So now we can equate coefficients of the same powers of x. We have, so for p, so for p, this one here in cube, that is equal to 2b, right? So our b should be equal to p over 2. That's equation 2. Now for q, this is q, the x squared, the second degree. So that would be equal to 2c plus b squared, which is this. That's equation 3. And then our r is actually equal to 2bc, which is our first degree x, right? That's equation 4. And last is the constant s, which is equal to c squared. That's equation 5, right? So let's move to the second page. So let's substitute equation 2. Okay, let me show you equation 2. Equation 2 into equation 4. So we will get the value of c, which is r over p. That's equation 6. And now let's substitute equation 2 and equation 6 to equation 3. We will get the value of q in terms of r and p. So this would be the first answer. So q would be equal to 2r plus p squared over 4. So you would get 2 points here if you answer this correctly. So let's take the value of s in terms of r and p. So we know that it is c squared and c is r over p. So squaring that would be s equals to r squared over p squared. So again, that's 2 points if you get that correctly. So already, okay, so we're done with that. So let's move to the fourth question. So this is a regression question. So uh, the easiest way to do this again is using technology. So let me show you how to do it in Excel. Of course, you can use any other software program to get the regression result for this. So okay, let me stop sharing that. Let's go to my Excel. So these are the data given in that question D2. So, and what we need to do is get the regression line. So let me show you first how to do regression analysis using Excel. So first is, if you see this, data analysis, click that, choose regression. And then since our, oops, I already inputted the Y value. So let me show you, if I click this part, and click from books up to this. So this is our y component, y values for our equation. Press enter and then input the x range. So our x values would be the gross revenue in dollar million. So again, highlight this and press enter. And make sure if you include the title or the label of those data for X and Y, you should check labels here. Otherwise, you'll get a wrong computation. So the output range, so simply choose where you want to put the result for your regression analysis. So if I click this, so I want to start my regression output here. So it's side by side with my table and click enter. I also click residual so I can see it. I think we would need it later in one of the questions. So, and hit OK. And that's it. You will get the summary output of your regression analysis, including the residual output. So, Okay, so I actually input this summary output in the solution of D4. So let's go back again to my other file. So let me stop sharing this. Okay, so already see that how to do regression using Excel. So the question for this problem is write the regression equation based on the result of the regression analysis. So and then two is how much of the variation in home video units can be explained by gross revenue. Three is the relationship between gross revenue and unit of books sold significant. So there is actually a requirement, explain it by information of R squared, p value, and the 95% confidence interval from the regression output. So if you answer question 1 and 2, so that there is 1 point each. And if you answer question number 3, that would be 2 points. So I just copied the regression result from Excel to this. So the regression equation would be books unit sold, that is our y, that is our dependent variable, equals 23.32 gross revenue, that's our x or our independent variable, minus 72.2, that's our intercept here. So if you see this, oops. So gross revenue is in this part of the coefficient here. So that's part. So you just need to multiply it to the x or to the independent variable, and then negative 72, which is this, plus error, right? And then let's go to question number 2. So R square from the regression output is the amount of variation in books units sold that is explained by this model. So simply look for the R square, so which is this line here. Oops. This line here, and that is 0.879 or 87.89%. So the amount of variation in books units sold is explainable by the relationship with the gross revenue, which is 87.89%. Okay, that's question number 2. And then let's go to question number 3. So is it significant? So the question is yes, the relationship between gross revenue and books units sold are significant. And we need to explain in terms of the three parameter that was mentioned in the question. The first is because of a high R squared value, right? That's 87.89, meaning 87.89 of the variation in books units sold can be explained by the relationship with the gross revenue. Okay, that's one. And then in terms of p-value, so our p-value, let's go back to the regression output. So you can find the p-value here, which is 1.269 uh, raised to the negative 10. So you have 10 zeros in front of the number. So what did I say here? So which is below so our significance level is 5%. So definitely our p-value is below that. This indicates that we can be 95% confident that the true slope is not zero. So because our null hypothesis is always that beta is zero, right? Which is our slope, our true slope. So we reject the null hypothesis, and therefore there is a significant linear relationship between the gross revenue and the books unit sold. Because if this is zero, then there's no significant relationship between the books unit sold and gross revenue, right? Okay, so for the third explanation why it is significant using the confidence interval. So if you look at the again to the summary output of the regression analysis, let's go back there. So you can find it here. Gross revenue, right? From 19.28 or 29 which is the lower 95%. So that's the lower limit. We did this earlier, right, by hand. And the upper 95%, which is 27.36. So from that boundary, from that range or interval, so what did we say here? It does not contain zero, right? Because 19 from 19 to 27.36, there is no zero between them. And that indicates that we can be 95% confident that there is a significant relationship between the gross revenue and books units sold. If it contains zero, then it's not significant, right? So since in this range, there is no zero, so therefore it is significant. And we are 95% confident that there would be a significant linear relationship. Okay, so if you answered all of this, you would get 2 points for question number three. Okay, let's move to the next question. Again, this question was given in elimination round three. So if you watch Math Agility Live episode 13, you would be able again to answer this question quickly. Okay, so the question is, at the American Historical Museum, a gold plate has a Hebrew inscription as in the figure below. So this is an inscription in Hebrew, and the following translations are given in Roman numerals, right? So sim so the question is, find the general law suggested by these numbers written in Hebrew, express it in the mathematical notation and prove it. So points criteria is that we need to translate it in Roman numeral. So you will be able to do that easily because we have given the translation, and then answer the general law and of this mathematical notation and then prove it. So of course, by merely looking at the table, you would be easily able to translate it. So this is given. So 1 equals 1. 1 minus 4 equals negative quantity 1 plus 2. 1 minus 4 plus 9 is 1 plus 2 plus 3. And 1 minus 4 plus 9 minus 16 is negative quantity 1 plus 2 plus 3 plus 4. So we can find that the general law for this number is, so the sign changes, right? From starting from positive to negative. So we know that there will be a component for this. Negative 1 and minus 1, right? So if you try putting n equals 1, so that's 1 minus 1, right? And that would be 0. So any number raised to 0 would be 1. So we got a positive. If you use n equals 2, so 2 minus 1 is 1, right? So you would get a negative sign on the second term, and that would be alternating series of positive and negative when you use this factor here. And we also see that our series is actually a square of the number of n, right? So n1, n squared. So if 1 is n, that is 1. If our n is 2, that is 4, which is this. And if n is 3, 3 squared, that would be 9. If n is 4, that will be 16. That's why we got a 16 here. So, okay. And then for the right-hand side, if we use, what do you call this? Some of the series, you would know, again, uh, we we will be able to prove that the sum of the n squared series would be n quantity n plus 1 over 2. So we didn't show the computation here, but you can easily check it by solving that. And now let's prove. So let's go to the next part. So now let's prove to use a step from n to n plus 1. So if they would be equal, so from negative 1 to n plus n plus 1 squared equals to negative 1 n n plus 1, n plus 2 over 2 minus negative n minus 1, quantity n plus 1 over 2. So manipulating this, we would be able to get, uh, and I factor out negative 1 n here, and then combining these two terms, which is n squared plus 3n plus 2 over 2 plus n squared plus n over 2. So we can add them up. We have the same denominator. So that would be 2n squared plus 4n plus 2, and divide by 2. We get n squared plus 2n plus 1, which is exactly the same as the one on the left-hand side of the equation. So that's it. We have proven that they are equal. Okay, so hey, that's it. So that's already question number 5. If you have any other questions, you can write down on the comment section. And once again, let me congratulate the semi-finalists for Elimination Round 4. Let me just show you, share my screen. So congratulations to MC or Mac Noriel Baldonado, Cephai Mars Liklikan, Ivan James Lorenzo, Aljon Tomeldan, Aisel Kate Lucero, Sander Banyaga, J. Lord de Vera, Jules Bros Malagum, Kresna Joy Marcos, Art Elizar Vera, Carl Justin Berses, Joshua James Xavier, Jean Callejo, J. Mark Sodsod, James Michael Espos, William Paul Barbiran, Aljim Flores, Jimmy Nunez, and Ronald Munoz. So congratulations, and we will see you in the semifinals round. Okay, so thank you again for watching us today at Math Agility Live. So see you next Thursday. God bless everyone and stay safe.